Hello everyone. So in our last class, we talked about the definition of pasteurization, and we learned about the basic definition and why do we need to use pasteurization, right? But in this class, we'll go through more details about uh, the classification of the pasteurization. So there are three types of pasteurization. The first is called low temperature, long time heating, in abbreviation LTLT, which is 63 degrees C for a minimum of 30 minutes. And then the second type of pasteurization is high temperature, short time heating, in short HTHST, which is 72 degrees C for a minimum of 15 seconds. And then there's also a third type of pasteurization that is called UHT, ultra high temperature. So temperature is much higher at 135 degrees C, above the boiling temperature. And it's typically 2 seconds, sometimes even longer. So now let's compare the HTST milk and the UHT milk. We didn't include the LTLT milk into comparison, the long time low temperature milk, because it's really used right now in the industry. Okay, so you can see that the major difference is their shelf life. So for HTST milk, it usually does not last for very long, about 2 to 3 weeks. But for the UHT milk, it can provide much longer shelf life, 2 to 3 months. Okay. And also, if we look at color and flavor, the HTST milk does preserve more color and flavor. However, for the UHT milk, it does not preserve the color and flavor that much. And if we look at the protein denaturation for HTST, because the temperature is 72 degrees C, so most of the protein is still not denatured. But for the UHT, it will cause structural damages to the protein structure, which is called denaturation. Okay, so we can find a lot of those products. So as I said, not much produced by low temperature long time, LTOT. And this one is the only one that I can find from Google. You cannot even find any in the grocery store. And you can see most of them is still UHT. I would say majority of them in the market is UHT, ultra pasteurized. Okay. And there's even one called ultra filtered. So ultra filtered is a little bit different from ultra pasteurization. So ultra filtration, basically we pushing the milk through a membrane. So the membrane will filter out those small molecules like water, lactose, and some minerals, but the proteins will be condensed. So whenever you see the ultrafiltered milk, it probably contains more protein, but doesn't necessarily say it's ultra pasteurization. So that's two concepts. Okay. And also we have some sterilized milk. So sterilization, as we said, it's a very intense process that kills almost all the bacteria and the spores. So it's the heating is more rigorous compared to the UHT and the HTST. So they typically does not require to be stored in the refrigerator, but they can be stored in the room temperature. So you may wonder, how does the sterilized milk compare to the ultra pasteurized milk? The answer is the sterilized milk will require a aseptic processing, and you can see one thing is that their processing temperature is very similar, but the holding time of the aseptic milk is much longer. And also, the production of sterilized milk will require a very rigorous aseptic condition, especially the packaging step, which we'll actually go through more in the following classes. Okay, now let's come back to summarize some key features about pasteurization. So, when we talk about milk is pasteurized, then we're talking about 100% of killing those pathogenic bacteria. But for other bacteria, for example, spoiling bacteria, there's only about 90 to 95% of reduction. Okay, so eventually the milk, pasteurized milk, will still go through spoilage. And the second is the enzyme deactivation. So it inactivates especially the lipase, because lipase can break down fat and cause rancidity. So when we talk about food is pasteurized, it typically refers to the high temperature short time processing, HTST. So that type of milk will be good for 2 to 3 weeks. So the long time low temperature processing, LTLT, is very rarely used because it requires 30 minutes of cooking time. So if we're talking about 30 minutes, that's probably a batch processing, and we all know batch processing is not very efficient. So if we're talking about milk is ultra pasteurized, then it usually refers to UHT, which is 280 degree F or 135 degree C for 2 seconds. If there's a sterile packaging, then that will producing aseptic processing. So that food can be stored under unrefrigerated condition for 3 months. But once it's opened, we have to refrigerate right away. So we have always been talking about milk, but beyond milk, what else do you think can be pasteurized? Well, the answer is all of them. So you'll see that for a lot of beers, juices, even liquid eggs and syrups, low alcoholic beverages, actually a lot of them are produced by pasteurization. So depending on their pH, we use different strategies and the purpose is very different. So we know there are two types of foods: low acid foods, which is pH higher than 4.5, and acidic foods, which is pH lower than 4.5. So for low acidic foods, the purpose is to kill pathogens. So in milk, the targeting bacteria is Brucella abortis. But if we talk about the liquid egg, then targeting bacteria is mainly Salmonella. Okay, and the secondary purpose is to reduce the spoilage microorganisms and enzymes. Okay, so in that case, we can extend shelf life from 1 to 2 days to several days or weeks. But for high acid food, we know the pathogen is typically not a big concern. So why do we still want to pasteurize them? Well, here's the table showing why are we doing so. So depending on the type of food, for example, if we're dealing with fruit juice, the main goal here is to inactivate enzymes, especially the pectin enzymes. And then secondary purpose is to kill the spoilage microorganisms. But in beers, the goal is to kill spoilage microorganisms, and then there's no secondary purpose. But if we look at the items below, which are the low acidic foods, high pH, and then all the purpose is to kill pathogens. Okay? So very different purpose here. All right, just to summarize, For acidic foods, the goal of doing pasteurization is to kill spoilage microorganisms like yeasts, molds, and the lactate-producing bacteria. And also we want to inactivate enzymes, for example, the pectin methyl esterase. So we just talked about the LTLT is not very commonly used in current food industry because it requires 30 minutes. So it's hard to make it into a continuous process. So in that case, it's usually a batch process. But for the HTST and the UHT, those are typically continuous process. So if we're doing batch process, we know that we have to use a kettle, right? So this is an open jacketed boiling pans, which we can do a small scale batch pasteurization for liquid foods. If we're doing a continuous process, we'll need a heat exchanger, right? So we talked about the plate heat exchanger and the tube heat exchanger, which are both very robust in terms of increasing temperature or dropping temperature. So this is a shell tube heat exchanger, which is very similar to the one that we have in the DPTC, the Dairy Center. So in your 330 class or 474 class, will take you to a tour to the facility, and you will be able to see the pasteurization system there. It's very huge system. Okay, finally, let's talk about the nutrition part of the pasteurization. So as we know, compared to boiling or sterilization, pasteurization is a relatively mild heat treatment. So there's usually a very minor change in terms of sensory and the nutrition facts. And the pigments are also all mostly unaffected, so the color still looks very vivid. And the table below compares the nutrition before and after pasteurization, and you can see the change is very minor. For example, thiamine changes about 77%, and for vitamin C, because vitamin C is extremely heat sensitive, so all that will decrease by 20 to 25%. Folate about 0 to 10%. Vitamin B12 about 0 to 10%, and the serum protein will lose about 5%. So you can see it's a very mild process. Okay, so finally, let's summarize what we have learned in this class. So at the very beginning, we talk about the concept and the purpose of pasteurization, right? So the pasteurization is mainly to kill the pathogens if we are dealing with milk, right? If we are dealing with a very acidic foods, then the main goal is to kill the enzymes and the spoilage microorganisms. And then we talk about three types of pasteurization. LT stands for long time, low temperature. HTST is high temperature, short time. UHT is ultra high temperature, right? So you're supposed to remember their particular time and their temperature. For example, LT is 63 degrees C, HTST 72 degrees C, and the UHT is 135 degrees C. So those are required to memorize. And also we learn about low acid food and high acid food. Why are we especially why are we passionalizing the high acidic food, right? Because there are enzymes and spoilage concerns. And finally, we went through some nutrition aspect. So the nutrition damage is very, very minor. Okay, typically just a small portion of the nutrition will be lost during the pressurization. Okay, so that summarizes this class.